Now we have problem 16 of our cryptarithms. Take that sheet. Again, we can begin by writing out our digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And based off of our observation, we can see that S must have to be a 1, so we'll cross that out. And so t plus itself must equal a 2-digit number. So t can be 9, 8, 7, 6, or 5. It can't be 4 because 4 is too small. 4 plus 4 is 8, which is only a 1-digit number. Now when we look in the ones place, we see that something, which is e plus t will give us t. And this will only work out if e equals 0. Now, if in the ones place, something plus a 1-digit number equals the 1-digit number itself, then it means that there is nothing being carried to the tens place. Now we can see that k plus a, they can't equal 0, they have to equal 10. So k plus a equals 10, which means a 1 is carried to the hundreds place. And when we look in the hundreds place, we see that 1 plus a plus h gives us another 10. And of course, this is including our carried 1 over here. So a plus h themselves must be only a 9. So again, we can write it out. K plus a equals 10. A plus h equals 9. Actually, I'll rewrite that. I'll rewrite the order. H plus a equals 9. And this tells us that k is always 1 more than h. And if in the hundreds place we add it up to equal 10, that means the 10 is carried to the thousands place. So now we have 1 plus t gives us h. Because t is being added to itself, t plus t must already equal an even number. So now when we look in the thousands place, we see that h must be an odd number. What are all the odd numbers available? 3, 5, 7, and 9. And remember, k always has to be 1 more than h. And because 9 is the biggest digit we have, h can't be the biggest. And now we can write the values of k. K has corresponding values, 4, 6, and 8. Now we have narrowed our options down, so we could go ahead and test our values out. If h equals 3, t equals 6, and k would be 4. But then you can see that in the tens place, a would also have to be 6, but 6 is already taken by t. They can't be 6 at the same time. So this possibility does not work out. Now what if we do h equals 5? If h equals 5, then t would equal 7, and k would be 6. A would be 4, and 4, and that does work out. But we still have to test out h equals 7. If h equals 7, then t would equal 8, and k would also equal 8. But t and k cannot equal 8 at the same time. They are different letters, which means that this possibility will not work out. This leaves us with only one possibility, which is h equals 5 and k equals 6. And that is our solution. So let's go ahead and write out our answer more clearly. We know that s equals 1, e equals 0, h equals 5, k equals 6, and we still have a and t. So what would a and t equal? So if we put our values in, 5, 5, t would be 7. So t is 7, and if t is 7, k is 6. So a would be 4, and this is our solution. Here's problem 17. Memo from Homer. Again, right off the bat, we see that h must equal 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can cross 1 out, and we can write h equals 1. And when we look in the ones and tens place, we see something interesting. We see that o plus m gives us r, but then in the tens place, o plus m gives us e. It's the same two addends being added together, except their sum is different. This must mean that a 1 was carried to the tens place. So e would always be 1 more than r. E is 1 more than R. And we have the letter M. So M, since it's the leftmost digit in the number memo, M can't be 0. And since 1 is already taken by H, M also cannot be 1. M can be 2, 3, 4, 5, 6, 7, 8, all the way up to 9. And we can see that O can never equal 0. Because if O equals 0, here the ones place wouldn't work out. O can equal anything besides 0 and 1. O can equal 2, 3, 4, 5, 6, 7, 8, and 9. What if we have M equals 2? If we have M equals 2, F would need to equal 9 in order for us to carry this H. But if we have a 9 here, we would end up with 11. And H and O cannot be 1 at the same time. So that wouldn't work out. What if we carried a 1 over here? So 1 plus 2 would give us 3. 3 plus 9 would give us 12. But O and M cannot be 2 at the same time. So no matter what, M cannot equal 2. And we can move on to M equals 3. Sometimes you really just got to slow down and test every single possibility out. If M equals 3, then one of our biggest options to make F is 9. From looking at the hundreds place, we see that the hundreds place must have equaled 13, not just 3. So then O would be 4. But the ones place must add up to equal a 2-digit number. So this wouldn't work out. If M equals 4, then again, there must be a 1 carried to the thousands place. And we're going to try to make O as big as possible. So that would mean making F a 9. 1 plus 4 plus 9 gives us 14. O and M cannot be 4 at the same time. So if F equals 9 doesn't work out, what if we have F equals 8? 1 plus 4 plus 8 gives us 13. But as you can see, in the ones place, we do not have a 2-digit number. So this still wouldn't work out either way. Now what if we had M equals 5? If M equals 5, and we tried to make O as big as possible, F equals 9, and O would equal 4. In this case, it wouldn't work out because 4 plus 5 in the ones place would only equal a 1-digit number. But what if we said, oh, a 1 is carried to the thousands place? 1 plus 5 plus 9 gives us 16. But in the ones place, we have 6 plus 5, which gives us 11. And H and R cannot be 1 at the same time. So M equals 5 does not work out. Now what if we had M equals 6? If we have M equals 6, then H, let's try to make O as big as possible, would equal 9, O would equal 5, but R cannot be 1. Now what if a 1 is carried to the thousands place? O would equal 6. M and O cannot be 6 at the same time. So now let's retry. M equals 7. Instead of making F9 this time, we can make F8. In this case, we would get O equals 5, R equals 2, and for E, we would get 3. As you can see, this wouldn't work out in the hundreds place. Now what if we had F equals 6? O would be 3, R would be 0, and E would be 1. But this wouldn't work out. And there's no point in going down any further, or else we won't be able to carry this 1 to the tens place. So no matter what, M equals 7 does not work out. What if M equals 8? If M equals 8, remember, F equals 9 wouldn't work out. We could do F equals 7. This would make O 5, and E would be 4. As you can see, this does work out, which means that our solution is H equals 1, M equals 8, O equals 5, F equals 7, E equals 4, and R equals 3. That's our solution. And now we've come back to Cryptarithm number 18, seen some bones. We can begin by writing out our digits from 0 to 9. And we see that B is a carried 1, so we could just write B equals 1. And S added to itself must equal a 2-digit number. So S could be 9, 8, 7, 6, or 5. It can't be 4 because 4 plus 4 is only 8. That is not a 2-digit number. And in the 10th place, we see E plus M equals E itself. So this tells us that M equals 0. But M could also have another possibility. M could also equal 9. Because if M equals 9 and a 1 is carried, it would still technically be 10 plus E equals something that ends with an E. So M could be 0 or 9. And since we have M down to only 2 possibilities, we can just use trial and error. What if M equals 9? Then it means a 1 must get carried to the 10th place and another 1 is carried to the 100th place. And if M equals 9, we're going to have to test out the values of S. M already equals 9, so S can't be 9. S cannot equal 8 because then it wouldn't work out in the 1's place. S couldn't be 7 because, again, it wouldn't work out in the 1's place. And what if S equaled 6? Well, if we had S equaled 6, it still wouldn't work out. We would have no values for N or E. So what if S equaled 5? Well, if S equals 5, then these S's are also 5. And as you can see, O would have to be 0. And you might ask, oh, why can't O be 1 and a 1 is carried to the thousands place? Well, that's because this digit is already taken by B. So we can't carry this to the thousands place and have O also being 1. So then O would be 0. And so what possibilities could N and E be? N plus B, in this case, must equal 15. So they can't be 9, so they can be 8 or 7. And that's actually it. And so N would be 8, E would be 7. This does work out, doesn't it? So we can write if M equals O, then S equals 5. Now what if M equaled 0? If M equaled 0, there can't be anything carried to the 10th place. It also means that nothing would be carried to the 100th place. So if we had S equals 9, N and E will have a lot of different possibilities. S equals 9, we look in the 100th place and we see that this is impossible. Remember, nothing must get carried to the thousands place, or else this O will also become a 9. We have to keep S and O different digits. 8 in the 100th place added to E must equal a 1-digit number. The only way for that to be possible would be making E a 1. 1 is already taken by our letter B. So then this wouldn't work out. S couldn't be 9 then. And now what if we had S equals 8? If S equals 8, O could be 6 or 7. So this could be 6 or 7. If N and E equals 2 and 6, so if O already equals 6, then N and E can't be 2 and 6. So then they would have to be 3 and 5. 3 or 5 in whichever order wouldn't work at all in the 100th place. So then this entire thing, S equals 8, would not work out. Now what if we had S equals 7? If we have S equals 7, then N and E could be 2 and 5 or 3 and 4. Let's say that we took N and E equals 2 and 5. E equals 5 and N equals 2. This is impossible because then O would have to be 7. 7 is already taken by S. So what if we switch the order? E equals 2 now and N equals F. Then O would have to be 3. But this again wouldn't work out in the thousands place. O would have to be a 4. This possibility, N and E equals 2 and 5, would not work out. Then what if we had N and E equals 3 and 4? If we have N equals 4, E equals 3, O would have to be 1. But 1 is already taken by B, so this is not possible. So again, we can swap the order. E is 4 and N is 3. As you can see, we would have to carry a 1 to the thousands place, and O would have to be 9 in the hundreds place. In the thousands place, O would have to be a 5. O can't be 5 and 9 at the same time, so this possibility wouldn't work out either, which means that this entire scenario, S equaling to 7, would not work out. What if we had S equals 6? N and E can be 2 and 4, and that's about it. So let's say that N and E equals 2 and 4. O would have to be 8, and we would have to carry to the thousandth place. But again, O cannot be 3 and 8 at the same time. So now we can change the order. Now N equals 4 and E equals 2. So then O would have to be 2. But E and O cannot be 2 at the same time. So that's controversial. But it also means that we get to cross another possibility out. Now what if S equaled 5? As you can see, this already will not work out. If S equals 5, then O would have to be 0. O and M cannot be 0 at the same time. And if you said, well, what if we carried a 1 to the thousandth place? O, in this case, would have to be 1. But B and O cannot be 1 at the same time. So no matter what, S cannot be 5. This must mean that our only possibility is M equals 9 and S equals 5. So let's go ahead and put that in. So O would be 0, and there would be no carrying. There would be a 1 carried here, a 1 carried here, and N would be 3, and E would be 2. So this is our solution, guys. Let's rewrite it. B equals 1, S equals 5, O equals 0, E equals 2, M equals 9, and N equals 3. That is our solution. This is problem 19, our 19th cryptarithm. Nina, sing again. And this problem is actually very simple. So we can begin by writing out our digits. 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 9. And again, we see that A is a carried digit in the 10,000ths place. And because there are only 2 add-ins being added together, this carried A must be a 1. And now when we look in the hundreds place, we see that I plus I gives us 1. So if A equals 1, then what could I be? Well, then I could only be 2 different digits. It could either be 0 and a 1 is carried, or it could be 5 and a 1 is carried. As you can see, no matter what, in both scenarios, with I being 0 or 5, there is always a 1 carried to the hundreds place. So now, since we've narrowed it all the way down to I equals 0 or 5, we could just go ahead and do trial and error. What if I equaled 5? If I equaled 5, then in the tens place, N would have to be 7, right? And there would have to be a 1 carried to the tens place. But this is impossible to do because in the ones place, no 1-digit number plus a 1 would give us 17. So then I equals 5 would not work out. This leaves us with only one possible answer, which is I equals 0, right? So then N would be 5. And there would be nothing being carried to the tens place. So then G would be 4. And again, here the N equals 5. And S would be 9. So there we have it. It's a very quick problem. Now let's rewrite our solution. A equals 1. I equals 0. N equals 5. G equals 4. And S equals 9. That is our solution. Welcome back to 3 Inquisitive Kids, and this is our 20th cryptarithm. Meet most teens. Again, we can start by writing out our digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Again, we can see that T must be 1. It's a carry digit of 2 add-ins being added together. And if T equals 1, then S in the ones place would be 2. And when we look in the thousands place, we see that M added to itself must equal a 2-digit number. So what numbers could M be? M could be 9, 8, 7, 6, or 5. It can't be 4 because 4 plus 4 is too little. It's not a 2-digit number. And we can start testing things out. If M equals 9, E will equal 8. And what could E be? E could be 3, 4, 5, 6, 7, 8, or 9. So let's start out by testing out what E could be. If E equals 3, then N would equal 5. O would have to be 0. M would have no value because E would have to be an even number. So E does not work out. We can actually cross out all of the odd numbers for E. we can see that no matter what, O would always be 0. So now what if E equaled 4? If E equals 4, then M would be 7 and N would be 6. So this does work out. If E equals 6, then N would be 8. And then there would be a carry digit to the thousands place. And now we don't know what to do for the thousands place because M plus M must be an even number. So now what if we had E equals 8? So if we had E equals 8, N would have to be 0. And we can already see that this wouldn't work out because O is already 0. So the only value of E that would make sense here would be E equals 4. And N would be 6, and M would be 7. So let's go ahead and write our solution. Our solution is T equals 1, S equals 2, M equals 7, E equals 4, N equals 6, and O equals 0. That is our solution.